Roberto, welcome everyone. Let's start the session. We have like 45 minutes. We have two presentations, one from Roberto, one from me. Each will take 15 minutes. Please give your questions after the talk. And let's start. Please, Roberto.
Thank you very much. I'm going to share my, I'm going to share my presentation. Well, hello, good morning. My name is Roberto Feeney from Argentina, Austral University. Today I will present a work in progress regarding the challenges of emerging bioplastic value chains. Plastics are an affordable and versatile material with a huge and growing range of applications. However, bioplastics have strong negative externalities as they release polluted material into the environment. They are almost non-degradable and complete recycling is unfeasible. So it has proposed to substitute plastic for bioplastic products. However, the emergence of these bio-based value chains face many challenges. This is the topic of my presentation. The presentation follow in the following order: the context of the problem, research questions, methodology, highlights of the literature, research conclusions. First of all, there is an increasing amount of publications regarding the plastic problem. Approximately 350 million tons are produced globally each year, and there is an increasing production in the following years. It's forecast that by 2050, more than 1,000 million tons are going to be produced. But also, the plastic sector will account for 20% of the total oil consumption and more or less 15% of the global annual carbon budget by that year, 2050. So also, the greenhouse gas emissions from plastic could represent 10 to 13% of the entire remaining carbon budget. And the annual cost, annual economic cost of plastic pollution can be figured by $2.2 trillion, and subsidies are around $5 trillion. It's a huge amount of money too. So plastic pollution and its substitution for more sustainable raw materials has been an issue in the UN climate summits since the early 2000s, and as it carries the promise of a more sustainable material. So the purpose of this exploratory work is to ask which are the challenges of the bioplastic value chain in order for it to emerge as an successful value chain. Which are the limits? What limits the development of this market, and which are the challenges for these value chains? The methodology is based on the literature review with these keywords: the challenges of bio-based value chains, combined with a case method focused, a case study focused on the Argentine case. Bioplastics can mean many things, and it can be understood as bio-based, biodegradable, or featuring both properties. Bioplastics are not just one single substance, they comprise a whole family of materials. And here is a little bit the problem. Bioplastics can be used as an umbrella term to encompass many types of materials, some that do not fit into the consumer's basic understanding, basically that people expect bioplastic to be bio-based and biodegradable, but those two concepts don't go together. So bio-based not always means that the material can be biodegradable. There are some bioplastics that are non-biodegradable, and conventional plastics are mostly non-biodegradable, but there are some that are biodegradable. So we can see that consumers are a little bit confused on what bioplastics mean. The literature, previous research reporting on barriers to development of different bio-based value chains include works by Carraresi, Mertens, Berg, Widra, Locke, Kish, Bolgi. Our findings are going to be in terms of economic, sustainability, logistics, and supply chain, and adoption and innovation. The main economic challenges that bioplastic value chains face is the high economic cost and possible lower performance than conventional plastics. And secondly, achieving economies of scale in the initial stage of production adoption, which if you don't achieve it, will refrain needed investment. Also, an adequate feedstock selection, as they saw, raw material cost normally account for 40 to 60% of the total bioplastic account. And also the construction of sustainable business models with attractive value propositions in terms of environmental impact of the bioplastic is important. In terms of prices, this is a big challenge as bioplastic or bio-based plastics are much more expensive than conventional plastics, as we can see in this table. In terms of sustainability challenges, basically actors involved in the bio-based value chain must consider developing mechanisms to reduce the overall consumption of energy, water, and materials. This is the first environmental challenge. Also limiting the use of biomass to its renewable rate. You have to balance the use and the production of this material, reducing the emission of greenhouse gases, and reusing waste for other products that can be used as inputs, and finally substituting the non-renewable energy for renewable energy. And there are also different social economic challenges too. In terms of innovation, bioplastics should be perceived as a green innovation, and that they can fulfill the promise of being biodegradable or even compostable under the right conditions. But in order to exploit the market potential of bioplastics, it's important to understand consumer acceptance and the factors that will lead them to adopt the product. However, not much is known about consumer acceptance, and there are many challenges regarding communication and education. The sustainability of bioplastic production, is that a feature that will lead consumers to adopt more bioplastics or not? That is another question. In terms of logistics and supply chain challenges, the bio-based value chains are very special types of supply chains, because the biomass material normally has a low bulk density, which makes it costly to transport from the farm field to the biorefinery without being properly processed. So biomass availability, ensure a continuous biomass supply as collected only over a small period of the year, design this supply chain to reduce cost, ensuring the optimal use of biomass and cascading efficiency are some of the challenges. In terms of the case study, we interviewed 3 managers out of the 5 companies that we identified that exist in Argentina. So we are going to go to the general findings. Basically, bioplastics is an unknown product in Argentina. The market has not emerged, and faces some issues such as the lack of a national legislative framework, important financial and tax related challenges. The market is very small, and there is a certain lack of know-how in the industrial scaling, as most projects start in a lab and they must be scaled up, which brings several challenges. However, there are many opportunities, especially the abundance and variety of biomass, which is as cheap a resource that is available to use, complementary with certain know-how to transform the biomass into bioplastics. Another important fact is that the scientists needed to develop these projects are well trained, but also they are not very costly comparatively with other countries. And the investment needed and the scale of these projects is not so high. We are talking about projects of 2,000 to 10,000 tons a year and $5 to $10 million of investment. So some of the conclusions basically is that the bioplastic value chain is a very novel chain. And in spite of facing big challenges, the companies identify opportunities linked with specific needs in several niche markets in Argentina. The feedstocks to make bioplastics come from agricultural waste, and they're abundant and achieved by product. Biomass availability and continuous supply is not an issue. The market supply challenges from the mainstream market perspective are huge, as there is hardly any demand, as people in general do not know what use bioplastics have, and they are significant more expensive products than conventional plastics. The potential adoption comes from industries in which the bioplastic is a small fraction of the total cost, and which sustainability legitimacy is an important issue. Most bioplastics are intended to be used as drop-ins. There are no projects to make bioplastic with special features. Entrepreneurs face challenges not only regarding the inherent risks of bioplastic emerging value chains from a micro perspective, but this is important. There is a lack of an ecosystem environment in which would allow them to interact with universities and institutions to innovate. Additionally, there's no government support, and even if a scale of production is an issue, the needed scale to break even is a small fraction than conventional plastics. And finally, in spite of all this, the abundance of biomass and certain know-how encourages some local firms to make projects to provide with bioplastics to international markets. That is the opportunity, as the Argentine market is relatively small. And the final remarks is that this case could be potentially, we have to see it in future, an important case of natural resource-based industries as developed by Anderson and Wickett. Basically, in these type of natural resource-based industries, the technology trajectory is conditioned by natural resources, and innovation and industrial dynamics are associated to these natural resources. There are many studies that have demonstrated that in these natural resource-based industries, there can be a source of important innovations and technological opportunities. For that, you have to combine a mix of general technology knowledge with particular in situ knowledge to create unique knowledge base which constitutes a competitive advantage for local-based firms. However, in order to succeed, it needs a complementary public research system, and that is something that maybe it's lacking in the case of Argentina. Well, this is a very fast presentation. Thank you for attending this presentation, and I'm available for questions.
Thank you, Roberto. All right, the next presenter is me. let me, so I need to share my screen, right? And is it this one? I think it's working now. Yes, welcome everyone. This is my presentation. This is a joint work with Justus Wessler and Bodevan Brand. Me and Justus is from the same group, Agriculture, Economics and Policy Group, and Bodevan is from the Wiring and Research part of the university. And this is an economic review of a specific biopolymer, which is called Cyanophycin, which we produce out of tobacco. And we cultivate this tobacco in Argentina. Let's talk step by step. Like so, in the plenary session, we were discussing that how do we tackle climate change, right? Like one of the things that you can come up with, like one of the first things that comes to mind is to reduce the fossil-based input, right? The consumption of fossil raw material. Now, this project goes along those ways that instead of using fossil-based plastic, we produce bioplastics from tobacco, which I think would fall in line with what we have been discussing this morning. Now, I'm going to talk about the Cyanophycin itself, just to give you a general idea. I'm not a chemist, but I will just give you a general idea, general knowledge about this product, this chemical, and then this biopolymer. Then I will just briefly talk about the project. Then the major thing I wanted to show you how much it costs to produce such a thing. Okay. Then if we will still have time, we will talk about some more math-oriented theoretical stuff. But mostly, I want to talk about here is the production costs. Okay, so Cyanophycin is actually first introduced and expressed in cyanobacteria. It has one backbone and two side groups. You can see it there with those red dotted line. In the middle, you have the backbone, and on the sides, L-arginines are the side groups, and they are all amino acids. Now, as I said, they first expressed in bacteria and yeast. Why it's so? I want to compare this. Why it's nice to produce this in bacteria, and I also want to compare it in tobacco. I think these are not substitute to each other. I think these are complementary to each other, but I still want to show you what is more advantageous in which production line, right? So you can come up with higher expression levels of CGP in the bacteria. It's a flexible production system, and no, you don't need any arable plant, right, compared to tobacco. But then you're talking about a high capital investment for such production line, and it's harder to increase the scale. So when you compare it to plants, it's obvious that, for example, there's a use of arable land as a negative aspect, as a disadvantage. We are still figuring it out. So there's no such thing before us that tries to do this in plants to figure out the Cyanophycin. So we are still figuring it out. This how much expression we see in the tobacco, how do we purify the Cyanophycin. This is all still ongoing, part of the project. And then compared to bacterial production, we see lower expression levels. But then use of arable land in a way allows us to have a very large production capacity at the same time, right? And we also have byproducts with this. I will show you how we process the whole thing, and you will see how we separate the leaves and the seeds, and then from the seeds you get the byproducts, right? And we can already use the existing infrastructure because we are talking about farming here at the end of the day, and costs are obviously lower. Well, there are potential applications. I'm not saying that these have been done, but
Again, this is not my area of expertise, but the people who are part of the projects, they are also saying that these are the areas that we can explore with this product. But here today, I will only talk about what would happen if we take Cyanophycin itself, this biodegradable chemical itself, as the product itself, outcome itself, not these, right? These are application areas which is important, that it has a lot of features, right? It can be a detergent ingredient, direct component for bioplastic and biopackaging. This is what we actually had in mind also, generally. And we also did consumer analysis on that regard. And in medical field, tissue engineering, drug delivery, you know, the coating of the drugs, anti-cancer drugs. Agricultural, it can be a fertilizer, plant growth promoter, food supplement, and again, we have byproducts, oil and feed. Okay, let's talk about the project itself. This has been running for 3-4 years now already. The idea is to cultivate the tobacco in Argentina, and we have a biorefinery there, which is called the company called Bioceres, where we also extract the CGP there, then import to Europe. This is the whole idea how we process this, and then further, after receiving it in CGP in Europe, further processing it into several different production lines, or just do this as the product itself and make a market out of it. There's not much market going on either, right? It's a very, very niche market, let's say. We finished the 3rd field trial. We're going to go for the 4th field trial. So what do we do here? So we try to sustainably substitute fossil raw materials and economically feasible and sustainable production line. Those are the 2 main things that we're trying to achieve for Cyanophycin. So what was the plan in Argentina? So we agreed that the production will, the cultivation of tobacco will be in Salta, which is a very prominent tobacco production land, state, region. There is about 16,000 hectares of tobacco fields. So quite a large amount. And if you see that, I mean, it's not very accurate, but that red dot is the Rosario. It's close to Buenos Aires, and that is where the Bioceres is. So you see that there's some travel back and forth, but we also calculate those in our production cost analysis. There's also the idea that maybe that in the future another refinery in Salta or like close to the fields. Okay, so this is the process. We can go 2 sides. We can just go directly for drying. Then drying will allow us to, with threshing and cleaning, separate the leaves and the seeds. Seeds will press and create press cake and oil. And from the leaves, we create the CGP, we extract the CGP. Well, at the beginning, we weren't sure exactly where we were going to see more CGP. Will it be in the seeds, will it be in the leaves? But at the end, after 3rd field trial, we figured out that, okay, we need to stick with the leaves. Or you go for silage, half drying, you put them in just cut them all, put them in silages, and then just on the extraction of CGP. And we don't really have this, obviously the process gets shorter and easier, but at the same time, we don't really have the byproducts. Okay, so this is a study, it's been done in 2020 for Salta, for a production of tobacco Virginia. It costs around 6,300 USD per hectare. This is the cost. I'm not going to get into the details of what's what there, Then we figured that, well, it's 2020. We don't know exactly what happened from this time to 2022. So let's go check our own prices. With the help of our project partner Bioceres, we figured out these prices. We are talking, we see here around 2,000 USD per hectare for labor costs. So we are talking about 120 days, 8 hours labors each day. Fertilizer cost, land cost, greenhouse irrigation, others, and transportation to Bioceres, which ends up around 7,000 USD per hectare, which is not a far cry from what we had from the other data, which is nice. Now, so you might ask, okay, you have this amount of leaves per hectare, so how much CGP you can produce out of it? So there's this yield penalty we have, there's the CGP content. Well, I wrote there 3% also, but we already figured out a way. So there are lines of tobacco lines, that shows 4% consistently so far. But I just wanted to have, because it depends on quite a lot of things. The CGP expression in the leaves, it depends on the weather, it depends on the irrigation. So I wanted to have a lower bound there. This is, you can think of it as a bad case scenario. But we achieved 4%. And also the isolation, at the start we were assuming that the isolation will be around 55%. We achieved 70% so far, but I will just keep it for the sake of being modest about numbers, 55 there. And purification, this is standard. So we see something in between 26 kilogram to 35 kilogram, 35, 36 kilogram of CGP per hectare. And if you up this isolation to 70%, you can go all the way up to 45 kilogram. Okay. So what do we is a general idea of what do we see as a benefit and a cost, a revenue we see here. So the yields, as you can see up there. So you can approach this problem as a fine chemical and a bulk chemical. Right? If you're just talking about CGP, just sell it by kilos, that's more like a bulk chemical idea, right? But you can also approach this problem as a very specific product for a very specific issue, right? You have this example here, the Bahem H arginine product, which is not exactly what you can achieve from the CGP that we produce, but something very close to that. And the prices of those are astronomical, as you can see it here. So there is so much opportunity going on, even if we approach this problem as a bulk chemical, right? In the modest scenario, you see here that it's around 1,000 USD per hectare. Okay, then we can go back and see what was the cyanobacteria production line is achieving. So so this is a paper from Salam and Steinbüchel from 2010, and they show that in a 5,000 liter of fermenter, the production capacity is around 1,250 kilogram per year, which boils down to 25 to 30 hectare from our perspective. And then the production costs around 3 to 570 USD per kilogram. Now, let's go look other products which we can say fine chemicals, but are also in the market, which are dipeptides. This alanine glutamine product, which you can end up per kilogram around $5,000, and sarganor is about $3,900, so $4,000. So we are seeing here a market price over $3,000 as a fine chemical of an application, a dipeptide application of CGP. So you see, I just showed you a price of 225. This was just a general, what we had with the discussions in the market. So what would this sell, right? And we came up with this number. And imagine this was 3,000. Okay, just byproducts. So there's you can do the cold press and the oil press. Now what I took here is the sunflower oil, which is a pretty close example of what would happen if you press tobacco leaves. Well, these numbers were before all the crisis was happening. The numbers of, I'm guessing, because in sunflower is also coming quite a lot from Ukraine, but the prices are quite higher now. I'm guessing. I didn't check those, but you see that there's like a byproduct revenue that you can see. But I should also add, this is assuming that this is a very best case scenario, right? Because when you allow leaves to grow, seeds are not really growing that far away. So here, these numbers are coming from these papers where they only focus on seeds. If we grow seeds, how much seeds we can grow. So this is a bit like a best case scenario for byproducts. Let's say it like that. So what are the challenges we are facing right now? Well, obviously increasing the CGP content, right? We expressed 4% so far. Maybe further develop the purification process. I showed you that isolation is around 70%. And the extraction of byproducts, because it's always easier methods to use the silage compared to, the other process. And also more market research, because it's a very, very niche market. It's not much information available out there about Cyanophycin consumer, let's say it like that. Cyanophycin demand. I think I want to just quickly, like we are also been hearing in the plenary sessions about how import policies needs to be adjusted to make it more available for GM products to be able to import to Europe. Like we have been discussing all this. We have been discussing all these issues since morning and yesterday also. So there are two ways to approach this problem. I told you that CGP can be imported as a product itself to Europe, further developed for applications. And now we can see this application process as like food and feed or importable process. What we are assuming and what we are thinking to do is to apply for import for processing. Although importable processing takes longer, according to the data. Now this part is the uncertainty part that we have been discussing about innovation, right? You don't know how long it will take. The same thing goes for the R&D. When you do R&D, you don't know how long it will take to finish your R&D research, right? Then the approval is another thing. Then you have the benefit side. So we have this structure, right? The first and the R&D phase, then the approval phase, then the market and liability phase, right? The third phase is where you reap the benefits and also you face liabilities that your product causes, right? And each one of them has their own time frame, which is uncertain. Now here, we can approach, I'm not going to be able to tell those because I don't have any more time, but here you can approach these problems by using real options methodology, right? We just had a discussion about cost-benefit analysis in the plenary session, which was that we had the same line of thinking, right? And I think it's very important to use these kind of methodologies to understand how, when we face these kind of issues about, oh, there's this investment opportunity. Should I be investing now to this opportunity or should I wait in the future when the things are better and invest then? To make these comparisons, you need these kind of financial models to be able to figure this out. I will not be able to get into the rest of the financial model. Maybe it's also good for because it's almost lunchtime. Okay, then I will just, these are the references and thank you.